Right, real quick. Let's review section C real quick. Right, problem C. Yep, problem C. Right, so I'm one. Billy takes a 300 milligram blood pressure tablet every morning at the same time. Now the drug decays exponentially in the bloodstream at a constant hourly rate of k equals 0.12. So for every hour, it's reduced by 0.12. Now there are two questions in this particular section. There's how many milligram of the drug remains in the body 24 hours later, just for the second dose, and how much just before the third dose. Then we have P in the long run, how much of the drug remains in the body just before each new dose. And then we even got a hint. Use the exponential decay formula. Thank you, whoever made this question. This actually helped me a lot. First, let's get over some basics, which is the most important part, the exponential decay formula over here. Right, so based on my digging and research, because there's no way I can do this by myself. Don't worry, I didn't ask anybody. I researched this by myself. So from this exponential decay formula, I deducted that A equals the dose. I don't know what the exponential is for in this specific context, but K equals the decay rate. Okay, we already know that. And T equals time. So answer number one, how many milligrams the drug remains in the body? Now, I'm not sure if there's actually a numerical answer to this, but since there's an exponential here, I kind of guess that there isn't, so I'm sorry if I'm wrong there. So, first of all, A actually has two questions instead of one, which is just make two questions at that point, whatever. So, A, the second tablet. Now, as you can see here, using the exponential decay formula, A equals A0 times exponential to the power of negative k times t. So what's A for 4? It's the dose. Okay, dose. Dose is 300 milligrams. Okay, so let the 300 times the exponential to the power of negative k times t. Okay, so k, that was the decay rate, 0.12 times the time. Let's see. How did I get 24 here? Okay, so how many milligrams the drug emits about 24 hours later? Just before the second dose. So 0.12 times 24. Well, if I'm not using a calculator, I would just calculate this in like 24 times 12 divided by 100. But since I have the power of a calculator, since this is not a test, which is cool, I just use a calculator. Okay, so its result is 300 times exponential to the power of 2.88 milligrams. Like I said, I don't think there's a clear numerical answer to this because there's exponential. Alright, now to A, to the third tablet. So still the same formula, still the same dose, still the same decay rate, still the same exponential, because of course. So what's the difference? Difference is how much just before the third dose. Okay, so how do we get the time of the third dose? So the thing is, the starting point is still the same. The starting point is still the first tablet, so it still starts at 0. Then since the second day is 24 hours, the third day must be just add an additional 24 hours. Since, just before the second one, it's 24 hours later. So we can assume that the third one is also 24 hours, just before. So just add up 24 plus 24. We get exponential to the power of negative 0.12 times 48. So the result is 300 times exponential 5.76 milligrams. Okay, now move on to B. Okay, to be honest, I don't really quite understand B that much, but well, okay, let's try, sure. So B, in the long run, how much of the drug remains in the body just before each new dose? From how I see it, this is supposed to have the numerical answer, and what I don't get is in the long run. but how much of the drug remains in the body just before each dose? I think I know the formula to that. So of course we're still gonna use the same exponential decay formula, because of course that's the only formula we have now. But the difference is we have an A instead of an A0. We don't have a dose. Wait, hold on, I'm confused. My own answer, god damn it. Whatever. Since there's no dose, just the time, so we only need to really count the time. So no dose, this is immediately 0 for the A, since A equals dose and there's no dose, blah 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 blah. So the dose is 0, so the only thing you really need to count is the exponential, which is negative 0.12 times 24. So wait, isn't that just the same? Well, yeah. Why is it 24? Because how much of the drug remains in the body just before each new dose. And remember, just before they take the second tablet, which is basically a new dose, it's been 24 hours, so it's supposed to be the same, unless I'm reading this wrong, but yeah. So yeah, it's pretty much the same as a second tablet, the only difference being that the dose is 0, so 0 times exponential to the power of a negative 2.88. At least I hope that is the answer too. And that's it. Wait, is there... Oh god damn it, section 2 has 2 questions. Alright, so quick video because section C number 1, I thought section C only had 1 question. So, quick answers. Number 2, pendulum oscillates with small angle displacement. Modeled by fx sin x. Billy wants to approximate sin x and need x p over 8 using a Taylor polynomial of degree 4. Write the degree 4 Taylor polynomial p for x centered at x equals p over 8. Set up blah blah blah. Okay, this is getting. Okay, so A, write the degree 4 Taylor polynomial. Right. So before we get to the degree polynomial, which is this jumbo, we need to derivative first. How many? Well, it asks for 4, degree 4, so derivative 4 times. Sin, cos, minus sin, minus cos, so back to sin. That doesn't matter, it's back to sin. Then we transform it again. This time replace x with the, there you go, with the value of x, which is p over 8. Right now, and then we put in the formula, which is Taylor polynomial. So what's the formula? It's this. It depends on the question, but you get the idea. P4, so it's only up to 3 or 4. Too long, so I'm just gonna say the answer. It's in p over x plus cos, yeah, that's cos, p over 8 x minus p da 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 blah 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 blah. Yeah, that's A. B is the error when corrected decimal place. Alright, so we have to use the Lagrange error bound, which is over here. Thank you for putting that in. And we gotta remember what was f5x, since right, so since it's 5 f5, so f derivative 5 is the derivative of sin, which is cos. And what's asked is less than 1/4 than 4, so yada yada yada, put in the formula from here. This is the formula, then just calculate normally, no fancy stuff, calculate normally. This is B. And then C, which is find the interval. Just basically just put it in the formula, right? Then simplify till we get the interval right here, over 8 minus that 0.1469 blah 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 blah, and this is the result. Let's see. All right, thank you.